Yay, 2.8. If you've made it to 2.8, you are definitely on the downhill slide. You're like almost hitting the bottom of the hill, actually. 2.8 is the last lesson for this week. 2.8, actually not that complicated. So it seems like it's complicated, not complicated. The biggest piece is that you just have to read it. Just take a second, don't panic, read it, and use some good old-fashioned logic. So start by reading page 77, 78, 79, and 80. And those are some just really, really good examples. If you have not read these really good examples, please stop listening to me telling you to read the examples and not doing it. Please read them. Okay, let's start off. Practice 2.8. Going to a wide screen, moving everything around. Boom. Getting all my tools in place up here. Perfect. So 2.8, all of those problems are extremely similar to the very beginning, before you even actually start seeing the yellow boxes. On page 77 at the very beginning, right under where it says, hey, you know what, word problems are exercises where an explanation is given instead of an equation. Like right below that, it kind of talks to you a little bit about how to do things where it says at. And what does that actually mean? So we'll just jump in. We'll do a couple. Let's just go ahead and do number one. It says 7 bananas at 15 cents each. Ooh, ugly cent sign. Ugh, even uglier cent sign. So all it wants me to do is multiply 7 and 15 cents. Now, this is the only place that it could be tricky, is 15 cents needs to be represented appropriately. So we need to represent it 0.15. So you can either put 7 and a raised dot 0.15, or you could put 7 and 0.15 in the parentheses. That's your 15 cents, okay? So make sure that you convert your cents over to dollars. And so handy dandy, I'm just going to put in 7 times 0.15, and I end up with $1.05. So 1.05, and you can go ahead and throw your dollar sign on there. Boom. That is your final answer for number one. Not complicated. You could totally do number two. Meet me back for number three. Alrighty, folks, number three. Number three says X plus 3 folders at 10 cents each. So it just means we don't know what X is. So some number plus 3 folders at 10 cents each. We don't know what the sum number is, but we do know that we can solve this problem. So X plus 3, since it's in parentheses, we're going to just assume it's exactly the same as when I used 7 a few minutes ago for 7 bananas at, okay, 10 cents each. I'm going to go ahead and put in that decimal form, and thank you, Rebecca, for putting in the decimal form for us. So all I have to do is just multiply X plus 3 times 0.1. Now, what I'm going to do here is I'm just going to distribute, like, boom, this one times this and this one times this. But I bet if I wrote it like this, you would like me a lot better. I bet if I flipped it and put the 0.10 here and then put X plus 3 on this side, so literally I'm just moving them, it looks a little bit more like a distributive property problem now. So 0.10 times X is just 0.10X. And then 0.10 times 3, just grab your calculator, 0.10 times 3. Oh, duh. It's 0.3. If any of you all got that without grabbing your calculator, my apologies for not getting that without grabbing my calculator. And my final answer is just going to be 0.10, and I can put some dollar signs, X plus 0.30, which is 30 cents. And this is it. Like, this is as far as you can go. This is your answer. I was even like looking myself over here at the answers just to make sure I wasn't supposed to take it any farther. And that's it. Okay, so that moves you on with number 3. I think you should be able to do 5. And I also think that you should be able to finish out that section. So finish out all the way through 9. And I will meet you back for problem 11. Welcome back. Problem 11. Easy peasy. So number 11 says, solve each problem using an equation. So I'm going to have to come up with an equation and then check the solution. Listen, a couple of you are slacking. Don't make me call you out on video. Please check all of your problems. Check the solutions. It's good for you. Okay, number 11, separate the number 39 into two parts so that the first number is 5 more than the second number. And what are the numbers? So here's what I want to do. First, I'm going to set up that I've got the first number is something. And then the second number is something. I got to figure out what they are. And then the total is something. So it says separate the number 39 into two parts. So the total is 39. That's the number that we're dealing with. And it says the first part, so that the first number is 5 more than the second number. So my second number is what I don't know. So I'm going to go ahead and call that X because that's my unknown. But then in my first number, it says so that the first number is 5 more than the second number. Well, I already said the second number was X, and the first number is just 5 more than X. Wow, not too complicated, right? So the total number was 39, and wants me to separate the number 39 into two parts. Here's a chunk that I don't know what it is. It's my second number. It's an X. And then here's another chunk, and the only thing I know is it's the same as the second number plus 5 more. That's what it tells me. So this is the information that I have so far, okay? Then it says, what are the numbers? So let's think this through. If I put the first number and the second number together, I'm going to get the total, right? So if I wanted to say my formula is first number plus second number equals total. We can agree that that makes sense. If I have a total, I'd separate it into two parts and then I put those two parts back together and I'm going to get the total. So we just said that the first number is X plus 5. So let's just replace it, X plus 5 plus, and we just said that the second number is X, so X. And we just said that the total is 39, so 39. So I have X plus 5 plus X equals 39. So that means that I'm going to have two X's. I'm going to combine those two like terms. This one right here, this X plus this X. I'm going to go ahead and keep my plus 5. It's not a like term, so he doesn't get to be combined. Equals 39. Got to get rid of that 5 because I want my X's all by themselves. So what I do to one side, I must do to the other. I'm just solving this good old-fashioned problem. So I've got 2x equals 34 because 39 take away 5 is 34. It says 2x, so that's 2 times x. Got to get that 2 out of the way. So divide by 2. So x is going to be 17. Now, the very last thing it says is what are the numbers? Okay, look back up here. So over here, it says 17 plus 5. So 17 plus 5 is 22. That's one number. That's number one. And then this is just 17 because we don't have to do anything extra. So when I'm looking for the answers, I'm looking for the numbers 22 and 17. And if you just want to get fancy and check, 22 plus 17 equals 39. Okay, and it does say check the solution, so you should actually do that. So here's your answer, and here's your check, and this is what I'm looking for. Okay, you should be able to do number 12, and then I will meet you back for number 15. Okay, I am back at number 15, just kind of taking a peek ahead to see what we have left in front of us. So number 15 it is. Number 15, one number is 70% more than another number, and the sum of the numbers is 405. What are the two numbers? It's exactly the same as the other one. So first number, second number, and the total. So the total is going to be 405. And it says the first one number is 70% more than another number. Okay, so the first number is whatever the number is, okay, whatever that number is, plus 70% more. Now, when you're using 70%, let me go ahead and just caution you that you should change this percentage into a decimal. So I would just rewrite this right now so that you don't get caught up on it later. You move the decimal over 2 places and it's 0.7. So the first number is x plus 0.7. The second number is just x, and the total is 405. So it says, what are the two numbers? This is exactly like the last problem. I'm only going to just set it up for you and then turn you loose. I'm going to add up first number plus second number, and that's going to give me my total. And we know that our total is 405. The first number is x plus the second, or actually, let me just stay true to form here. The first number is x plus 0.7, and the second number is just x. So you should have x plus 0.7 plus x equals 405. I did miss one little thing that I need to make sure I jump in here and make sure I tell you, is when we're dealing with it's 70% of the other number. One number is 70% more than the other number. I have to do 70% of this x, and I neglected to say that. So when I'm doing this 70% of x, that's like converting over my decimal and having 0.7x. So don't leave off this x like I did. So there's an x here. Okay. So you should have x plus 0, x and 0.7x equals 4.5. So I'm going to let you take it from here on adding up all these like terms and finishing out this problem. I have faith that you can do it. Okay, I'm going to turn you loose for the whole rest of this section, actually, or at least on page 81. And you are good. For me, I think we're good to go. The rest of these problems are just going to require a little bit of mathematical thinking. Do your best. If you have questions, please don't hesitate to email or ask. But I think you are on the road to success here. That is the end of chapter 2.8. Have a great time. You can do it. Bye.